In this first question, we have a student investigating two different aqueous electrolytes. So these are the kind of apparatus shown. As you could see, this is negative terminal, and that's because this shorter electrical circuit, well, the cell source is represented by the shorter one, which represent minus, and there is a plus. The minus electrode attracts positively charged ion. The negative electrode attracts positively charged ion, which are called cations. So the negative electrode is automatically called cathode, because it attracts cations and it attracts positively charged cations. Therefore, it serves as negative and not attracts an ion. In an electrolyte that can conduct electricity, that consists of the ions that you're going to do electrolysis on. If you do electrolysis of dilute sulfuric acid, so what are the ions present? You will have H plus and OH minus. That comes from the dilute bit, meaning it's in water, because it's aqueous, and all acids are essentially aqueous. They are dissolved in water to give you H plus ions. They are part of your definition. From the H2SO4 component, you have H plus and SO4 2 minus. And in terms of which one get preferentially discharged, well, the hydrogen ions will be preferentially discharged. Between the OH minus and the SO4 2 minus, the OH minus will be preferentially discharged. This is anode, which is positively charged, so the OH minus will go to the anode. And what you will get is, they don't ask you for the half equation, but you should know that there's a very important half equation involving the hydroxide giving you oxygen as well as water, and it's oxidation at the anode. Oxidation involves the loss of electron, whereas it's reduction at the cathode, because it's red cat. So these are the acronym that we came up with. Reduction happens at the cathode, and then you have oxidation is loss of electron, reduction is gain of electron. So gaining of electrons happen at the cathode, which attract cation. Therefore, cathode is negatively charged. So you have H plus electrons, in fact 2H plus 2 electrons, giving you H2 gas. That is why you get hydrogen gas, and you get effervescence of a colorless gas. I need to balance this equation. Whatever equation you write, have to balance it, because you're doing chemistry. So you have 4 hydroxide ions, you have 4 oxygen. So I need 2 oxygen there. And nope, I don't need 2 oxygen there. I need 2 hydrogen, well, 2 of that water. Then I get 4 hydrogen. 2 oxygen here plus 2 oxygen give me 4 oxygen. 4 times minus 1 is minus 4. So I need 4 electrons to balance the charges. These are the common half equation they like to ask you to write in theory paper, and you need to understand, appreciate that whatever you know from theory can also be asked in practical setting, such as this alternative to practical, and whatever that's asked in here could be applied to whatever that comes out in a theory paper, because chemistry is an experimental subject. So the type, well, the name of product that we're going to get will be oxygen. We can't give the formula because they specifically asked for name. And oxygen is a colorless gas, so I'll get the exact same observation as on the right hand side. I will see bubbles because I do not see a colorless gas, but essentially there's a gas produced because there's bubbles. So that's how I know it's colorless, because I don't see any color, but I know there's a gas because I see bubbles. Aqueous copper 2 sulfate, I will have copper 2 plus. Perhaps it's best if I just write it in here. Copper 2 plus SO4 2 minus. The aqueous itself refers to this H plus and OH minus. So between the copper 2 plus and H plus, the copper 2 plus will be preferentially discharged, and that is because copper is below hydrogen in the reactivity series. So the lower you are in the metal reactivity series, the more likely you are to be reduced, all right? The more likely you are to gain electron, okay? So instead of hydrogen at the cathode, you will get copper. And the observation you will see is, you will see a pink brown solid, forms, or you can say precipitate, it would be fine as well, something to indicate that there is a solid being given out. Between the anions, the sulfur and the OH minus, the OH minus again is preferentially discharged. It undergo oxidation as per this equation. Therefore, you also get oxygen gas, which is bubbles of colorless gas being produced again. So you need to state a test and observation to identify hydrogen gas. So when you put when you put a splinter that is still burning, okay, so you need the one with the fire, okay, you need the one with the fire. So you need a burning splint, so add, use a burning splint, not add. So something with the fire going, and because the hydrogen can react with oxygen gas and you get H2O, liquid. And you know that water is used to put out fire. So when you have fire going with a burning splint, it burns with the hydrogen gas, you produce water, and the water will put out the fire. So, but it will be very special because the hydrogen will combust, it will pop, it will produce a pop sound. So the gas actually get, well, the splinter actually get extinguished with a pop sound, all right? So the burning splint gets extinguished. Fire extinguisher means the fire gets put off, okay? But very importantly, because it's a hydrogen gas, so it gives off a pop sound while putting out the fire.